Hello everyone. In this video, we'll be discussing about stack data structure. So stack is a LIFO data structure, meaning that it the last in first out. It is like an array like we have here in this picture. One end is closed, another end is open. So it is only a one-ended data structure, one-ended data structure where you can insert the element from the one end and you can exit the element, take the element out from the same end. That's why we call it the last in first out data structure, because the element that you have inserted first will go at the bottom position. So suppose you want to insert 5, the 5 will go here. Then you want to insert 9, 9 is going to come here. And for example, then you insert 7, 7 is going to sit here. And when you take out the element from the stack, 7 will go out first, then 9 will go out, then 5 will go out. That's how stack works. So in this video, we are going to implement this stack. We are going to have our own stack class where we will be implementing this stack data structure in Java. So the process of inserting the element into a stack is called the push. We actually push the elements to the stack, and the process of taking the element out from the stack is called pop method. Right? So we are going to pop the methods, meaning that we are going to remove the element from the stack. We are going to push the element to the stack, meaning that we are going to add element on top of the stack. So what do we require in order to implement this into a Java class? Number one, obviously we require a push method and a pop method. We require one more thing, there is another concept that is called a top of the stack, top of a stack. So top means it is a variable or a pointer that actually keeps track on the top position of the stack. So right now, top is pointing to this position, that is 7, because that's the top of the stack position. If we pop 7 out, then top will point to 9. If we push one more element, for example, 8, so top is now going to point to this 8. So top is a variable that we will be using in order to keep track of top of the stack. There is another method called peek. So peek is a method that also returns whatever is on top of the stack. So it's different than pop. Pop will delete the element from the stack and will return the value. Whereas peek will return top of the stack value, but it will not delete the element from the stack, right? So with this foundation, let's jump into writing the code, Java code to implement this stack class, right? So what do we require is, let's say, first of all, what we need here is an int in this stack class is an integer, private integer top, right? So you can actually give this stack name to your own class, or you can have a different name. While there is a predefined stack class in Java library, you can import it from java.util package. That is a predefined stack class. You might think that it may coincide with that class. While this class that we are creating is in a different package, so you can have the same name, there is no problem. But if you want to change the name, it's up to you. So we require one variable with the name top. And one more important thing here, I want to make my stack class the general class. What do I mean by the general class is, say suppose if I want to insert integers, I can insert integers. If I want to insert double, I can insert double. Push double values onto the stack. For example, if I want to push string values, I may be able to push string values onto the stack. That means I want to make my stack general stack. I want to use generics in Java to implement this stack class, right? So for that, what I am going to do is I'm going to define my own data type, and the process of defining your own data type is very simple. Well, after after giving the class name, you can use these angular brackets and you can give the data type. Say, for example, T, whatever you want to give name to it, right? And now we need to actually create this stack actually that is an array implementation of the stack. You can actually have two implementations of the stack. One is through the array implementation, right? Another one is the linked list implementation. So in this video, I'm going to discuss about the array implementation of the stack. In coming video, I will be discussing about the linked list implementation of the stack. So in order to have this array implementation, we require this array first, right? So we require this array where we actually are going to store the values, right? So how we can define this type of array of the generic type? Like, what do I mean is, you can easily have an array of type integer, right? For example, integer array, say stack is equal to new of integer and the size that you want to define. But here we do not want to make it specific to the integer. So what we can do is the data type that we have defined by our own, we want to have that type of the variable or an array for that stack. So for example, stack. I'm just going to declare it. I will initialize this inside the constructor, right? Okay, now let me define the no argument constructor for this class, public stack. So in the no argument constructor, my assumption is that by default, the size of the stack is 5 elements. It can hold 5 elements. What I can do is I can simply say, I can simply initialize it. First of all, my top value will be 0 because this should be pointing to the 0 at when we are going to start with this stack. And then I'm going to initialize this stack is equal to new of now. Since you have your own user defined data type, how you can declare, create an array for that type. So what I'm going to do is I'm going to say object array, right? Object for, say, suppose of 5 size, right? That you can do. But then the type, this stack that you have declared here is of type T. So we have to typecast it to T. Right? So what I'm going to do here is I'm saying create an array of the object with capacity 5 and typecast it to the type T, that is my user defined type. And that's the stack that we have declared. Okay, what if the user want to give its own size to declare size? For example, integer size, right? So what we can do, we can actually do the same thing. Like, let me just copy this code from here and I can paste it here, right? So instead of this 5 now, we will be actually initializing it with size variable. Does that make sense, right? And now you can actually make this code more simpler by just calling this and passing 0 to it. That's it. So this will do the same job. If there is a no argument constructor, this is going to call this constructor by passing 0 as a size, sorry, 5 as a size, and then this will create 5, the array with the name stack of size 5. Okay, now we have this. Now let's move forward to write the actual methods. Let's say, for example, the first method that I am going to write is public void push, because the push method does not return anything, but it will accept the data that we want to push into the stack. What type of data it requires, it accepts is of type T, right? So it is going to push whatever is the data onto the stack. So let's see how we are going to do that. First of all, let me say what I'm going to do is I'm saying stack, that is my array of top position that is initially pointing to 0 is equal to the data element that we have received, right? And then once we are done with that, top should be increased so that next time whenever we are going to call push, top should be pointing to an empty slot of the stack, right? So that's how we are going to implement this push method in stack. Let's say, let me create another class so that we can test it whether we are able to push the elements into the stack or not. Let's say I am going to create, let's say we want to give the name to the class as the stack tester or any tester class, right? So, oh, okay. So it shouldn't be the package name. It's the name of the class, right? And we need a void main here. So I'm going to create this class. So what I am trying to do here in this void main is I want to create an object of my stack. So stack, so suppose S is equal to new of stack, right? So what you can do is when you call this constructor, this would be the position of the stack at this point. So this stack, this top is going to point to the 0th position of the stack, right? And this is an empty stack. Okay, once you have done with that, and then what's going to happen? So suppose you said s dot push, and you want to push 5, right? So in that case, what will happen? So you are actually going to push this 5 onto the 0th position of the stack. So 5 will be pushed here, right? And then the top will be incremented. So what does this mean is the top is now pointing to this position instead of this 0th position. So the next time, whenever you are going to call this stack, this push method, this will be pushing the value to the next position. Like for example, s dot push, you want to push, say, suppose hello, right? So that is a string value actually, right? So this will be pushed because you have defined a generic type, right? Anything you can push. You can make it the specialized one. How to do that? We will see that, right? So for example, in that case, at the first index, the hello will be written, right? So here you are going to write hello, right? That's how we are going to add the values to this stack. Okay, what next? Let's go back here and write another method. Say suppose public void print. So this print method actually will print the elements of the stack so that we can see whether really or not these elements are in the stack or not. So how we can do that? We can simply run a for loop, right? Integer that I, say suppose it starts with 0 and I is less than or equal to top, right? In fact, it is less than top, right? So less than top and I plus plus. And what I'm going to do here in this loop is simply print out, instead of using print ln, I'm using print the stack of ith position plus a comma and a space, right? So this will be printing my stack. So let's say, for example, if I go back to this stack tester class and if I call this show print method s.print, if you run this code, you will be able to see that these two elements are in this stack, right? For example, now you are going to insert s.push, say 5.6. So 5.6 will be pushed after hello, right? So say suppose now you are trying to push s.push 9. So 9 will be pushed onto the stack after 5.6. Right? That's how we are going to insert the value. So that's the position of the stack. Okay, for example, you want to make it generic only for the integers. So what do you need? You know that here you have to just define the integer in the angular bracket, right? And this stack now will only accept the integer values, right? So you can't give this string or a double type of value. You cannot do that. It only accepts now the integer values because you have defined a wrapper class here and you said that this stack is meant to store the integer values, right? This is fine now. What if I stored, okay, so let me just update this stack, that what is the current position of this stack now. So this stack does not have this hello anymore, right? So this stack is only having 5 and then 9, right? So then let's say once you have it, it's going to add 9 here, right? So 9. And then, for example, you added 7, it's going to add 7 here. Then you added 6, it's going to add 6 here. And by default, we haven't passed any argument here in the stack, the size value. So the default size of the stack is 5 that we have mentioned in our constructor. So what's going to happen if I have, say, suppose then 8 here, right? And after that, if this is the position of the stack now, where this top value is now pointing to the value that is not part of the stack, right? So, when it was 0, right? Initially it was 0, then we added top, one element, top was incremented. We added another element, top was incremented. We added one more element, top was incremented. We added 8, top is incremented, right? So once it is incremented, so top is pointing to a position that is not in the stack. So see the code of this. You added the value and then you incremented the stack, right? Okay, so what if I, let me add these values that I have written over here, that is 7, right? And then s dot push 6, s dot push 8. So you can verify that these values are in the stack. What if now, if I added one more value here, let's say 15. So the obvious answer is you are going to get an error, that is an exception, that array index out of bounds, because that index does not belong to this array that we are using as an stack. So what should I do in this situation? So it's very simple here in this stack class. We have to rewrite this push method now to test for this one. So one option is we do not allow user to enter more than 5 values if they haven't given any size or whatsoever. So we can check one thing here and we can print out. It is very easy that we can check if the top value is greater than 5 or greater than or equal to 5, we are going to print an error message, right? Instead of the exception. But the other way is we can actually make it flexible. What I want to do is what I mean is we can increase the size of the stack so that we can accommodate more values. How we can do that? Let's do it here. In the push method, first of all, I'm going to check if the top is greater than or equal to stack.length. So stack is an array. So what I'm going to check, if my top value, is it greater than or equal to the length of the array, right? Length of the stack. If that's the case, what we have to do? That means now we have to increase the capacity of our stack. How we can do that? For that, I'm going to create a temporary array of type T, right? Temporary array of type T. So suppose with the name temp, right? And this time I'm going to say new of object and the size, how much temporary array I'm going to declare. So suppose I want to make a double size. So what I can say is stack.length times 2. So what will happen after this line of code? A new array with the name temp will be created, right? Whatever is the current capacity of the stack times 2, right? Current length times 2. So once we have done that, what we need to do now? We need to copy the elements, all the elements from the stack to this temporary array, temporary stack with the name temp. So what I'm going to do is, with that I can do with a for loop integer I that starts with 0, I is less than or the stack dot length and I plus plus. And what I have to do is I am going to say temp of I is equal to the stack of I. So whatever is the value in the stack will be moved to the temporary array. So once we are done with that, after doing this, what I'm going to do is I'm going to say stack is equal to temp. So the temp that you have just created, make it a stack now, right? So in that case, we actually have replicated another stack of double size, and we reinitialize it with the same name. So once we are done with that, so this time we won't be getting an error or an exception, right? So what will happen now is if I do not have the capacity, right? If I do not have the capacity, initially it is 5, the length is 5, but we are going to add the 6th element. So you will be able to see it actually added 15. what happens is it actually created another stack of the size double. It increased the capacity of the stack, and then it accommodated the new element into the stack. So you are going to give more flexibility to your users, right? Make a flexible class. Okay, now let's write another method for popping an element from the stack. How we can pop an element from the stack? Let's say if let me write public, this will return, pop will return a value, obviously of the type would be same that is that the values that are stored in the stack, that is obviously t in our case, right? Pop. So here first thing that I have to check is if the stack is already empty and you want to pop an element, obviously again you will be getting an exception. So in order to avoid that, what I'm going to do is I'm going to check the condition first. If my top is less than or equal to 0, right, that means if top is 0, that means it is pointing to the 0th index and no element is in the stack, right? So in that case, we can simply print out a message for the user stack is empty, right? And we can actually exit from this code, system.exit, right? So that we do not have any troubles. If not, in other case, what we want to do is, let me create a temporary variable once again. So suppose data that will hold the value that whatever is at the top -1 position, right? Top -1 position. Why? The reason is again this simple. Like for example, let me just show you here. We added 8 and then the top was incremented. Then you added 15, the top is incremented to the next position. So top is pointing to some position that is not above the current value. So when I want to return, when I want to pop, I will pop 15, I will return 15, right? So the logic is simple. Top -1 value I will be returning, and I will decrease the top value so that top can point to this position once again. And then when I will pop, the top -1, that is 8, will be popped, and pop will decrement once again. So that's the logic that I'm going to use here. So what I'm going to do here is top data is equal to top -1, stack of top -1, and decrement this top minus, right? And after doing this, return whatever is the data value, right? So that's it. We are done with this pop method. Let's just test whether it works or not. So let's say if I, after pushing these values, let me do it after this print method. Let's say s.pop, right? So this will pop the 15, and now let me print the let me say sysout just to change a line that actually we can do it here in the print method. If in the print method, after coming out from the for loop, we can sysout here so that the line should be changed, right? Okay, so then we do not need it here. Okay, and then if I say s.print, it will print the remaining contents of the stack. Let's run this and see. So previously there was 15 on top of the stack and 15 is removed. Now, for example, if I call pop once again, so 8 should go, right? Let's see. So 8 is no more in the stack. So our pop method is also working well. Okay, so what if I pop all the elements? S.pop, let's say, and s.pop, s.pop, I popped 5 elements. I was having 6 elements in the stack. I popped 5 elements, so the last element is in the stack. What if I pop this element too? So you will be able to see the stack is now empty, right? So these values are being printed because of this print method, right? Now, if you want to pop once again, you will be getting the message printed on the screen that stack is empty instead of getting into exception. Okay, now let's write one more method that is this peak method, right? So the peak method, how we can write a peek method. Peek method is easier, right? Because in the peek method, you do not need to remove the value. Instead, you just need to return the value. So what I'm going to do is public, this will return a value of type T, peek, right? Or you sometimes we call it top of the stack, right? TOS. In some books, you will find top of the stack. In some books, Java actually call it peek. So what we are going to do, the same thing. If top is less than or equal to 0, we are going to say print a message, sys out, stack is empty, right? Otherwise, and let me just do the exit as well, system.exit with 0. And in other case, return whatever is at the top -1. So do not decrement top here. So we do not need top minus, right? We want to make the top at the same one, but we just want to return whatever is on top of the stack. So let's say, for example, if I comment all these pops, and now if I say s dot peek, so this is going to return me a value that I can store, or either I can simply print it out s dot peek, right? So let me just comment this as well. So you will be able to see that it says 15. Let me just make it fancy. Top of the stack is this one, right? Plus. So you will be able to see that it says top of the stack is 15. So say suppose if you pushed one more value here, s dot push, say you push 45. So this time it is going to tell you top of the stack is 45. Say suppose you actually popped one element from the stack, right? So now top of the stack will once again be 15. You pushed one more element. So suppose it will say the top of the stack is now 8. So that's how push, pop, and top of the stack are working. You can actually call this pop method that is going to return a value, right? That you can store and then you can print. For example, integer x is equal to pop, s dot pop, right? So then you can use this x later on, for example, to print out the value, right? So you want to use this to print the values. Let's say, for example, the value of the x, value of x is equal to whatever is the value of the x that you can actually use, right? So that's going to change the value. So you can see pop has actually removed 8 from the stack, and then you call peek. Peek is going to tell you that top of the stack is 6, right? But even after the peek, you again try to print this stack, you will be able to see that the 6 is in the stack. That's the difference between peek and pop. All right, so that's all with this stack class. It's a very simple data structure, but very useful. It has a lot of application. Operating system uses it a lot. Your compilers uses them a lot to check the parenthesis balance. If they check, balanced parentheses, they need to check to reverse a string. They need to check whether a string is a palindrome or not. They are especially used to convert the infix notations to the postfix notations. So in the coming videos, we'll see some of the applications and the code for those applications in Java. Until then, take care and bye.